Yes, sir.
So hope it is visible to everybody. So from my personal side and from my institute side, from BITS Pilani, I welcome all of you and to this particular session. And I'm very happy and glad and honored to be in front of you and to present some of the thoughts into the machine learning domain that are related to the recommendation system today. I'm Dr. Kamlesh Tiwari, as you already know, and I'm assistant professor in the Department of Computer Science and Information System at BITS Pilani side. So today we are going to talk about the recommendation systems and some ideas about that. Feel free to interrupt me at any point of time and unmute yourself and speak whenever a need arises. So I would love to hear your voices and interact. So whatever I'm telling, it would be nice that if you can ask all the relevant question, maybe uh, either by unmuting yourself and using the mic or by typing the things. I would try to see that whatever you are typing on the chat screen. So I need your support whenever I'm teaching something. I always like to understand that whether you are understanding the things into the same way or not. So first of all, a lot of good evening messages from all of you. So I thank everybody for saying these messages and kindly accept good evening from my side also. And I'm sitting in right now. I'm sitting in Pilani, that is, and you are sitting at the West Bengal. And the distance between the West Bengal and Pilani is more than 2,000 kilometers. So what happens that a lot of um, a, a lot of time domain shifting also happens. So at this time, however, I can see the sun at my side. I believe that that may not be the directly case at your side. At least at the time when we would finish, definitely there would be a night, and I would be at the time of evening. So thank you very much. Thank you for sending the good evening messages, and let us start our discussion. All right. So today we are going to first try to see the introduction, that what do I mean by this recommendation system. Then we are going to see two important techniques that people generally use. One is the content-based recommendation and the collaborative filtering. We are going to see the details with respect to the machine learning primitives, and then we are going to see the conclusions. All right. I assume that all of you may maybe some of you may be having the already having some of the understanding of this particular topic, but from my perspective, when I'm going to teach this particular subject and going to present in front of you, I am assuming that nothing is known to you. So don't take any baggage. Whatever simple question comes to your mind, please ask. I would also try to be very basic and bring all the necessary things in front of you with the utmost details that I can. So if we, from very very high level perspective, try to understand that what is the recommender system. So it is some kind of software tool, okay, or some kind of technique that we can utilize to find out that what to recommend somebody. So let's assume that there is a user, and we want to tell him that there is some item which is useful to him. Okay, there is some item that is useful to some user. How to find out that particular item and how to present that item to the user? This is what the problem of the recommender system. So uh, they want to pick some of the items which they think that is most useful to the user, and we are going to recommend to the person. This recommendation includes what item to buy. Lot of items could be there. So what item to buy? You know that nowadays we have plenty of the items available. Even you can see that at the Corona time when the people don't have anything. So now we have specialized shops that are only talking about the Corona related equipments and safety gears, etc. And so many things are there. So which particular item I should show to somebody so that he is more interested in buying the things? Ultimately, everything boils down to the sales, and we want to improve the sales. What music to listen? You know that there are lots of music tracks available. If you know that what is the kind of um, what is the kind of liking of a particular person, then we can tailor the kind of the music that around him, and he would be more interested in that. The same music that is being liked by one person may not be liked by the another person, and that's why it's a very interesting area that which music we should tell, which online article to read. Lot of article everybody is writing in every minute. Which particular article we should read, that is again a very important and crucial point. Recommendation, when my system is going to make any recommendation, they are usually personalized, means they depends person to person. One person, if he want to if I am going to provide some kind of recommendation to one person, that may not be the same way useful to the another person. However, in some cases, we can find out that we can divide the persons into the groups, and we think that a kind of recommendation that I'm going to give may be suitable for a group. For example, if there are some college going students, so we can figure out that looks like that this particular item which I'm going to sell, that may be more interested towards the college going student or college going girls only. So there could be some items that we can target that looks like that these are for only for the first year student, these are only for the final year student. There could be something. For example, if I'm going to launch some kind of job portal, so I would like to engage only the final year students. So sometimes we can we can divide the peoples into group, and that particular group can be targeted, and this kind of recommendation can be only can go to that particular group only. However, we think that going on the individual level is also fine, but sometimes we can make it to the group level. Recommendations play very important role, and particularly with the highly rated internet website. You know that into the Amazon, it takes a lot of things. If something very interesting comes at your landing page, definitely you are going to buy that particular item. YouTube, very much important, very interesting application, because if something very interesting comes in front of you, definitely you would like to see that, and it increases your engagement with the YouTube. So very recently, I by myself had discovered that there is some new kind of thing that they have introduced called the short videos. So you may have seen that earlier when you go to the YouTube, this was not there. So you go there, you see some of the recommendation, and then you got fed up because every day the same kind of recommendation is coming to you. So you just see that thing and you close that and you go away. But these sort, that is a new kind of a thing that they have introduced. It's a very small 10 second or 20 seconds video. In that video, every time the things are going to change. So whenever you see that, you think that, okay, let me just quickly visit that. And it's very engaging. If you start seeing that short thing, it is only 10-second video, 20-second video. But if you going from one video to another, if you scroll down 100 videos, it is going to take a lot more time as compared to when you have actually seen only a single thing. So lot of engagement related thing can happen with this thing. Similar thing we want for the Netflix, and because if you open the Netflix and same kind of recommendation, lots of movies they have, but it is not possible to show all of them in front of you because the screen limitation is there is a screen limitation. Very few things can be shown on the screen. So how can we manage that particular small space effectively so that user, when he sees something, he clicks on that? Yahoo, you see that lot of news items are there. They want to engage you. What news item should be shown to you? Somebody would be interested in sports. Somebody would be interested in shopping. Somebody may be interested in academics, and somebody may be interested in politics. So what kind of thing that he should put at the top so that the people got more engagement with that? TripAdvisor, IMDb, all these things are examples that if you can build a better recommendation system, they are going to be more useful. This is a kind of graph that I wanted to tell you that this is a very interesting kind of graph where in one side I am going to put items. Okay, let's assume that you have a shop, and in shop lots of items are there, and I'm going to put the items into this particular slide. It means on the x-axis there are items. This is the first item, second item, third item. Let's assume that so many items are there, and I'm going to put them, because items, how can I put them one by one? So there could be some criteria. Let us think that the criteria is the popularity, that which item is more popular. Okay. Highest popular item I'm going to put at the beginning. So this particular item is more popular as compared to this one. As I moved it to more into the X direction, these items is lesser and lesser popular. But it doesn't mean that this item would not be utilized. Okay. Everybody, many of the time people are going to search this for this item also, but this item is more popular. Okay, if we want to understand that what is the sales associated with this particular item, so you would be surprised to see that the items which are actually more popular, they have exponential amount of sale. And therefore, as we go toward the lesser amount of lesser popular items, their sales decreases very sharply. Okay, so you know that nowadays number of item is also very large. It is practically kind of infinite, and that's why you see that whenever there is a shopkeeper, he is only dealing with a few kind of things. Okay, because there also a lot of varieties are there. So if we think that all the items, if you think in terms of all the items and very popular item, then you can definitely draw a line. You can say that in my shop, because these items are more going to be sold, so I would only keep these items in my shop, and these items I may not like to keep them because they are not selling too fast. Most of the time I can say that if maybe if possible, if somebody demands that item, then only I would have those items. Or if I have a online marketing setup, then I can say that I would put these item into online setting and put these items at my store, where the person can come and he can see all these things. So it is a very interesting thing that if you can find out these kind of recommendations, so they are very useful to you. Also remember one thing that we must remember from the very practical point of view, that if you have too many choices, then you are actually confused. Okay, if you are providing too many choices to a customer, then he actually get confused. So there was an experiment where their customer were divided into two categories, and there was a product. Let's assume that the product is let's not name is. Let's assume that there was some product A, and the person actually what they did, that they created 24 different kind of that particular product. Okay, for example, there are biscuits, so 24 different kind of biscuits are there, and and there is another group B, where they have only put 6 different kind of biscuits. Okay, there are two groups. One group's 24 kind of biscuits, another group only 6 kind of biscuits, and they have shown to everybody, the people who are passing by. They were showing them that see this and come and purchase. What happens that surprisingly, when the people have saw 24 kind of thing, they keep arriving to this. 60% of the people who were seeing these ads, they reached to the shop and tested. Here, where the 6 items were there, less people were reached. Only 40% people were to whom they have shown this advertisement. Only 40% people has actually reached over there. But when we try to understand that how many people actually gone and tested that one of the biscuits, so looks like that only 2% of the people have tested, and here also 2% of the people have tested who actually arrived over there. And if we want to see that what is the percentage of people who have done actually purchase, so this was an interesting story that 3% of the people has actually purchased, who actually have tested. Out of the people who have tested, 3% of the people has purchased. In this particular setting, 30% of the people who has actually tested, they have purchased. Okay, so giving too many choices is also not a good idea. In some of the setting, giving too many ideas is also not a good idea. So that's why when you are going to develop a recommender system, your recommender system should be very crisp, and you should be able to provide the items which are actually at the top should be very relevant, so that the person can go ahead and do a purchasing. What is the goal? What is the important goal of this kind of recommendation system? One goal is this: to increase the number of sales. Okay, you want to sell more items. This is the first thing. That is not a very difficult thing. This is the first objective. Everybody can think about this. Second objective is to sell more diverse items. Okay, what happens that if because the shop is very large, if you are not going to show the person, if somebody is coming to your shop and you don't show him the diverse set of items, so every time whatever is in his mind, he comes and he buys the same item again and again. So if you can do some kind of recommendations, so he can go and purchase a diverse set of item. He can next time he can come and he can purchase a different kind of items over there. It can increase the user satisfaction also, because now user is more satisfied, because when he came to your shop, you have interacted with him, you had provided him some kind of recommendation. He thought that he has done some choices, and therefore he is more satisfied. If you have not done any kind of thing, and let's assume that a particular item for which he has came, he have purchased that item, even then he would not be that much satisfied as compared to the cases when you have given him some recommendation and he have followed your recommendation. It also increases user fidelity, means the user would be more loyal to you. He would like to come to your shop if he find out your suggestions more useful. So definitely he would like to visit your shop better. Okay. Also, when you provide the recommendation to somebody, to the user, you want to get more understanding of what the user want actually, because if you can understand what the user want, then you can bring more relevant product to the shop. So this interaction also is very important, that when you do an interaction, you better understand that what actually the user want. What is the idea? Okay. Idea means how can you do that? Idea means how can you do that? What is the thing that you want to do? So first thing is this, that you find out some or all good items. Okay, whatever good items you have, you come up with those kind of item, and then you can supply those. You can ask from the user that can you take these kind of items. So first you have to filter out that what are the good items with you, and then you can ask from the user that please purchase that. Okay. Sometimes you want to do the annotation in context, means what? That for annotation in context means what? That that he want to purchase something. For example, he is coming to purchase the TV. Okay. TV can have various attributes. So you start telling him, sir, this particular TV has more brightness. Okay, this particular TV has more, it consumes less power, or it can offer you more channels. It have picture in picture. So outside you can only see the sales is there with respect to only TV. But inside when you go, you see that there is a more context that you are going to make available to the person. So he would be more interested in that. So by developing an idea of recommendation, you can gather more context. Okay. Recommendation also may sometimes required is a sequence or bundle. For example, what do I mean by this? That sometime if you want to sell a TV, so you don't tell that, sir, please purchase the TV. Instead, you should tell that, sir, would you like to see this particular serial? Okay. So if you tell him that, sir, if you do you want to see Ramayana, you may have you may be knowing that at the time when there was a telecast of the serial Ramayana, at that time many people have purchased the TV. So if somebody tells to somebody that looks now the technology has advanced and new kind of things has come, you please purchase, people would not purchase that until they find out that, okay, looks like that there is some serial and I would be able to see the serial. So you should bring the person's attention to this particular thing, that what are the sequences, means when he is buying that particular item, what are the sequence of things that he can do? You tell, sir, please purchase this. This particular TV has also had the feature that you can listen songs. You can listen FM also on this, maybe. Also, you bundle with some other things. For example, you can tell, sir, your house is very good and you have very good a very good other, for example, dining room. In that you can say that if you can put this particular TV, that would be more suitable as compared to the other TVs. So if you bundle some things, You can tells the person, sir, you have purchased these items. If you also purchase this particular item, then you would be able to complete something. You complete a set. So those things are also important. So why I'm emphasizing this thing, that when you are going to build a recommender system, you should think about these ideas, that okay, I would be considering these factors while developing the recommendation. Okay. Also, it is a very important thing that the recommender system should be credible. Okay, if somebody is recommending you something, you would not believe on him if you don't respect him, because you think that he is a liar and he is telling something to purchase. Definitely, you are not going to purchase that thing. So there should be some credibility associated with that. So what happens most of the time with these AI based artificial intelligence based recommender system, people start playing with that. They provide a different kind of absurd kind of inputs to the system and try to understand that whether the system is able to understand or not. So the system should also be able to handle those kind of absurd scenarios, so that it can develop some kind of credibility. If some wrong kind of inputs are provided, he should also show that he is actually not going to give absurd kind of outputs. By this, the system gets credibility, and now the recommendations that you are going to get, they are going to be more relevant, and the person are going to help them. Very important part is this, that sometime what happens, that a few customers that actually when they come to you for the purchasing, they want to express something. Okay, they have some idea and they want to express that thing. 1 minute, I think I have some. Yeah, sorry, I think connection has gone. 1 minute, let me reshare my screen. 1 minute, I'm yeah. So what I wanted to tell you, that sometime when someone you are going to provide the recommendation, his task is to understand something and express himself. So the person actually is not able to express, but when you provide the recommendation, he thinks that okay, this is the thing I wanted. Okay, person is going to, when the person has come to your shop, you are providing him the recommendation. It is a kind of help that you are providing him to express himself. So that's why you have to understand that what kind of person he is, so that you can provide the right kind of items to him to express himself. So your objective is not to sell only your product, but also your objective is to help the person to express himself. All right. So these are the very high level understanding that we have. Now let us understand that how you can build these kind of system. Okay, recommendation system techniques. How can you build a recommendation system? Broadly, there are only two techniques. But later we are going to see that actually few more techniques are there that people utilize to build this kind of system. One is called the content based. Okay, one is called the content based. What is the content based? You see that this particular person have what all the items he have purchased earlier, and based on that, you develop that looks like that this particular item I should propose him so that he would be able to purchase. Okay. Yes. One thing is the content based, where you are seeing that what is the content the person has already purchased, and then you are going to use that particular content to suggest him something new. Second is a very important and interesting category, where you are going to utilize the other person's choices to propose something interesting to this particular person. What happens? Let's assume that I know that these are the first year students. Okay, let's assume that these are the first year students, and they are purchasing some item A. Let's assume that they are purchasing some item A. Then if you find out there is any other first year student available, then it would be nice that if you can show the same advertisement to him. Okay, so collaborative filtering says that you are learning that what the other peoples are doing, and you are going to apply this kind of understanding on him. This is the second approach. Into the first approach, what was there, that for this particular person, you are seeing that what are the item he have purchased, and then based on that, you are going to suggest that what to purchase next. Second approach is you find out the similar kind of peoples in your database, and you see that what those peoples are purchasing, and you utilize this particular information to suggest something to him. The second one is called the collaborative filtering, and that is a very important thing. Why? Because this person most of the time want to purchase something new, and whatever he has purchased, nothing is new in that, because he have already purchased those kind of things. So if you want to make him a new purchase, so maybe from this you have to look from outside, and then you can bring the new component into his purchase or the further recommendations. And we can always think that if these are the two methods, so somehow we can mix these ideas, and we can develop a hybrid kind of approach to do all these things. So these are the two approaches. Broadly speaking, these are the two approaches only. But sometime if you get more generalization, so sometime you can come up with more ideas, such as then you can come up, you may come up with the 4 ideas. One is the knowledge-based recommendation system. You can say that there are a few knowledge-based recommendation system, content-based recommendation system, collaborative recommendation system, and demographic recommendation system. Okay, so you can come up with these 4 things. So however, as I told you that technically these 2 approaches are more dominant, but you can think there's 4 different approaches that can be utilized to make a recommendation system. What is knowledge-based recommendation system? Here it is, you can think that as a rule based, because you know that if somebody has purchased, for example, fish tank, and then after some time he would be coming to purchase the food for the fishes, food for the fish. So you can think like that. So there is some domain knowledge that actually is incorporated into the system, that what are the things over there, which kind of person is there. So maybe using rule based inferences, you are going to induct some of the knowledge to the system, and the system is going to see the what are the product database, means what are the thing the person had purchased, and then he understand, because this particular person has purchased the cars, and then after 1 year he is going to purchase the insurance of that particular car. So you can utilize these kind of domain knowledges, and maybe after 10 years he may need to change his tires, like that. So using domain knowledge and the product that he have purchased, you can develop a system, and here you can utilize the use, means what are the needs of the person, and you can tell that what are the things that need to be shown to the user. Content based, we have already talked about this. You just see that what are the product person has purchased, and based on that you develop some strategy, and then you say that what is the next project. Maybe you can also utilize the user's rating, because user has, whenever he has done the purchase, he have given some rating. So based on this, you can think that looks like that the person likes this item more, then you can give him better kind of recommendations. Next, we have seen that collaborative one. We have also talked about this a few minutes back, that users rating database I also need, because what other people's has given the rating, and based on that, I'm going to find out that what is this person's rating, and based on combining these things, we can give him the better recommendation. So out of these all possibilities, I think that this one is going to be the more effective one. Okay. Next one is a demographic one, and into the demographic one again, what the other peoples are purchasing. Based on that, you can suggest something. For example, if you live in South India, then there is Onam, and at the time of Onam, you can suggest that okay, go and purchase these kind of things. If you are living into the North India, maybe at the time of Deepavali, you can suggest that you can purchase these items. So at the time of Holi, you can suggest that you can purchase these kind of items. So you see that there is also demography, means where the person lives also have an important role in what the person is going to purchase. So you see that what other people are going to purchase in this particular time, and utilize this particular information for the demographics, and then you would be able to find out that looks like that this person would be more useful for that. Okay, so so this is the This is the overall picture when you want to develop these kind of system. So whenever you are going to develop these kind of systems, you have to use the data mining pipeline. Means you have to do some kind of data mining. You have to understand that lot of data that is given to you. How can you utilize on that, and how can you go ahead with that? Okay. So let me quickly tell you that what is the data mining and what are the different parts of the data mining, and that you have to understand. And what with respect to our problem also, we are going to understand that uh, how can we utilize that. So you know that into any data mining process, first thing would be the data. You have to collect somehow data. Okay. But whenever you are going to collect the data, you cannot directly utilize it. Okay. Because, for example, let's assume that into the machine learning domain, you are going to do something with respect to the health data. So into the health data, you know that now the doctors have developed thousands of the tests that is possible for you. Anybody who is going to be sick, I pray from the God nobody gets sick. But if somebody gets sick, they have thousands of tests that can be conducted on you. But if you first time go and you say that, sir, some kind of doctor, I have this kind of problem, so they would ask so many reports. Okay, those reports may not be available with you. You may be only available with one or two things. For example, when you go there, he can immediately can check that what is your temperature, what is your breath and breath rate, and what is your heartbeat, and so few things he can immediately find out. So those values are only available. If you are going to in front of the doctor, out of these 1,000 value, only few values would be available when you go to the doctor. So if I create a database that what information you have provided to me, there are some missing values. Okay, there are some missing values. Also, there are sometimes maybe possible that some irrelevant data is there. Okay, so if my database, if I am going and collecting a lot of data, for example, if you want to, if you are going to start a coaching institute, and you are going to collect the data from many of the people that what should be there into the coaching institutes. Okay, so you are asking this question from many of the peoples. So you see that some input has been provided by those peoples who don't have any child who is going to study, or some or they are not interested in this kind of scenario. So if you take their data, so if you put their data also in your database, then your database may not have any much significant with that data. So you have to do some kind of processing, means you have to remove some of the parts. So that is a very important part. Whenever you collect the data, you have to do some kind of things, and then after that you would be able to get that particular kind of data on which you can apply the analysis. Do you understand that? Whatever data, your raw data that you are going to get may not be useful. You have to do some kind of things. And few are mentioned over here that sometimes you want to find out which are the relevant thing. Then if you want to compare two items, then you have to develop the right kind of distance measure. You have to do some kind of sampling also. What is the sampling? If your data is very large, and you want to find out some kind of output out of that, so sometimes if the data is very large, and I'm telling that data is large means what? That you cannot process it. So how would you able to process that? So you have to do some kind of sampling. Let me tell you, let me give you an example. Let's assume that you have a database where these many numbers are there, only just numbers. These many numbers are there. So this is a very large number now. Let's assume that these many numbers are there. And I ask a question that what is the average of all these numbers? What is the average of all the number which are stored over there? How can you do that? How can you do that? Only possibility that for all the items you are going to find out the summation and then divide by the number of items which are there. So it is going to take a lot of time. This particular process is going to take the lot of time. Can I make it fast? Okay, yes, I can make it fast by doing what? Sampling. How can I do the sampling? Let's assume that I have taken only 1,000 items. So randomly you pick 1,000 items, find out their summation, divide by 1,000 and multiply by that number with this number. 1 into 10 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the power 10. You multiply whatever number you are going to get by this particular process by 10 to the power 10. Definitely you are not going to get the right answer, but your answer would be near to the thing because you have not done the complete computation. So you definitely cannot get the right answer, but your answer would be near to whatever is going to be the right answer. Okay. Okay, 1 minute. I think I have said that I have to multiply. I think you need not to multiply over here because 1,000 items you have find out because you need not to find out the summation. That's why you need not to multiply. So if you want to find out the average, this average is going to be very near to the average of all the numbers. Okay, and there are probabilistic guarantees that says that how many numbers you should take and then what is the probability that you would be near to the right answer. I'm not going to much into that particular detail, but the sampling actually provides you this kind of liberty by which by using those kind of things you can actually you can find out the near right answer if your database is very large. Very important step is the dimensionality reduction. If the lot of data is given to you, sometimes you want to perform the dimensionality reduction. What is the dimensionality reduction? So you know that if you want to store anything in our database, so for example, a particular item is there, you want to store into the database. So you cannot store the item into the database. You have to find out what are the properties. Okay, you take the sum of the properties. Let me say the first property is what is the weight, second property, what is the color, third property, what is the radius into x direction, y direction, z direction, and so many values that I'm going to, what is the temperature, what is so many, depending upon the item. I'm going to collect all these information. Every characteristic that I'm going to measure or collect is going to be a what it is? It is going to be a dimension. And if I keep increasing, then my data is going to be of the very high dimension. So very high dimension data has some problem. You may have heard about this, something called as a curse of dimensionality. Curse of dimensionality. What is the curse of dimensionality? I'm sorry, my handwriting is not that good. Hope you understand this thing. Okay, if you have any problem, please let me know. I can write once again. So I wanted to tell that curse of dimensionality comes when your data is of very high dimension. Then the curse of dimensionality comes. What is the curse of dimensionality? Into the machine learning, actually, we want to find out what is the similarity of the two items, and we expect that the similarity would be if two items are similar, their distance would be very lesser. Okay, so we think that if this is the space, item would be lying somewhere, and we are going to we are able to find out that where are the like items are residing. But if the dimensionality is very high, what happens that that all the data items actually lies on the border only. Okay, if the very high dimensional data is there, then all the data items are going to lie on the border only. Why? Because probability of this particular item lying on the border, you just see that, let's assume that 0.9 means with a very 0.01, let's assume that probability that it is going to be lie on the border is very less, means very high probability that the data is going to be inside. The probability that the data is going to be on the border is very less. Let's assume 0.1 only. If 10 attributes are there, then what is the probability that the data would be inside? Okay, so you can see that it is not on border on anyone. So it is 0.1 minus 0.1 to the power 9. Okay, this is the probability of the item going to be inside. Okay, on all the, because all the dimension the item should be there. So this is 0.9 to the power 9 becomes very small number. And especially when when the number of dimensions are very high, then this number becomes very small. Means what? All the data lies on the on the boundary. And if all the data lies on the boundary, then the notion of the similarity that the two items are near actually goes away. And that's why machine learning becomes difficult. We want to reduce the number of dimensions. That is the first thing that we have to do whenever a lot of data is given to me. How can I do that? So you know that there are some specific and settled notions that the people talk about called the PCA and the SVD, single value decomposition, and PCA. You can utilize this method to reduce the size, and then after doing all these things, let's assume that you have done the sampling, dimensionality reduction, removal of the items which are irrelevant, and done all kind of changes. Then after that, you get the data on which you can apply the analysis, machine learning analysis, ML analysis. Okay, now what kind of analysis you can apply? Either you can go for the prediction or you can go for the description. Into the prediction, you can do the classification, association rule mining, the description, association rule mining, or the clustering. You know that the classification method, KNN, decision tree, rule-based, Bayesian, SVM, artificial neural networks, and into the descriptive base where you want to do the clustering. There are K-means, density-based, message passing, hierarchical, many other methods are there. So we are not going to into much detail. Hope all of you understand this. If you want to ask any question, you can ask. When you apply these kind of thing, at the end you are going to get something on which you can apply the interpretations, and you can do the interpretation. And with this interpretation, you can develop what? Recommendations. Okay, if you want to do the recommendations, so you on this interpretation actually involves the recommendation. You have to develop the recommendation based engines. General machine learning flow. Let me tell you that actually this is also a very important thing. That most of the time, this is the. Let me tell you that what I mean by this particular diagram. This particular diagram actually try to show you that what is the flow of machine learning. That is a very important thing. Let me tell you why. You know that. Let's assume that let us only focus on the classification problem. Okay, and in the classification problem, let me say that two classes are 0 and 1. Okay, we have to tell that whether this particular item is into the class 0 or 1. Okay, so let's assume that there is some item x1 and it's x1 and its class is 0. Next item is x2, its class is 1. Next item is x3, its class is 1. Next class is x4, class is 0. I'm putting in things as a random only. Okay, so let's assume that there is some right thing is there. Okay, so here very important part is this, that this is the right thing. What is this x? X describes this particular item. As we earlier seen that there are various attributes. Using those attributes we are going to find out. So let's assume that there is an attribute called weight. You want to find out that what is the weight of that particular item. So there is some item, you want to find out its weight. And let's assume that the weight is 1.213134. Is it possible? Definitely, because if you keep measuring to your maximum satisfaction, everywhere you would be able to find out the digits. If you don't measure it precisely, definitely you can say that things are 1.2 only. Okay, the weight of item is this, but in your database, what is the weight written? 1.2. Okay, why? Because there is always some noise into your measurement, and you cannot go beyond that. If you are using a scale, you cannot measure less than 0.1 centimeter. Okay, but if you are using vernier calipers, you can go beyond. Definitely, it goes away with this kind of concept that how much precision there is with your measurement. Most of the time, when the items are going to have this kind of their actual value, but you would be coming up with these values. Why? Because of your limitation. So there is always error and noise into the data. So whatever values you are going to have over here, they are not perfect. Try to understand this. Actually, what should be the value? That value is not exposed to you. And this is the biggest problem into the machine learning domain, because whatever database that you present to the machine learning system, they are actually a changed version of the original data that we can safely assume. So the task of machine learning is this, that you are going to put some of the hypothesis functions, and one of the hypothesis function which best fits on this particular data is being written by this machine learning system. And you can, for very basic understanding, you can tell that this particular system is one by one going to evaluate all these functions, and whichever function is going to be fit best on this particular data, it is going to reply that as a hypothesis. And this is the function, this is the output of the function that you are going to utilize on the new kind of data items. So the biggest problem, as I told you, biggest problem you should remember is this, that the actual data is actually not available with you. This particular data, whatever data is shown to you, that in your database is not the actual data, because actual data need to be very high, of the very high precision that you don't have. Therefore, answer is going to be approximate, and therefore you are going to have error onto the machine learning based system. Now let us talk something about the similarity measures. And what are the similarity measures? That if two items are given to you, how can you find out that how similar these two items are? For all practical purposes, into the next or subsequent discussions, whenever I'm going to say that an item is X, what I mean that this item is a multivariate, means lot of attributes it has. I can say that it has X0, X1, X2, ... Xn, n number of features and number of attributes are associated with that. When I write X, you assume that there are n different values are is written with respect to that particular thing. Okay, next item, that is y. Also again, y is also y0 plus y1 dot 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 yn different values. And most of the time into the machine learning setting, you know that this x0 and y0, they are specialized term and their value is always 1. So if you want to find out how similar these items are, so one method is, everybody knows, Euclidean distance. Euclidean distance. How can you find out Euclidean distance? Term by term difference. You just see that what is the difference between these items, what is the difference of these items. You see that term by term difference, make a square of that particular quantity. Whatever difference you are going to find out, make a square of that thing, square of that thing, square of that thing, find out the summation of this thing. Okay. And I think I have missed this particular quantity. You have to divide this by divide this summation by k. Okay. No. So if two only, I want to find out the distance between two items only. So this formula is fine. Okay. So then I find out the summation and take the under root of that. Okay. Take the under root of that particular quantity. This is how I can find out that what is the distance. Distance, if I can measure two items which are similar, their distance is going to be lesser. Next method is a more generalization of this Euclidean one, and that tells that instead of having this square, you can put any number over here, and then taking square root also says that 1 upon r. So if I'm going to use this kind of setting for finding out the distance, then it is called the Minkowski distance. When r is equal to 2, it is Euclidean distance. Otherwise, we can find out which particular distance actually suits to my problem. Next is the Mahalanobis distance. That distance actually uses the concept of the spread of the data, where there is a covariance. You find out that what is the covariance of that particular two data items, and you put the inverse of that particular quantity over here. Here, x minus y means what? Two vectors. So x was a vector, y was a vector. X minus y means term by term difference of these two vectors. And this multiply by transpose means what? Taking square only. Because if you take the transpose, it becomes in this way, and then you can do the term by term multiplication, because two vectors, when they are multiplied, it is multiplication term by term. And then you take the square root of that particular quantity. So this is called the Mahalanobis distance. Next important distance is, and that is the most important used distance into the machine learning domain, is the cosine dissimilarity. Okay, if you want to find out the cosine distance, so this is going to be into this particular formula is this, that term by term you find out what is the multiplication, and the norm. Norm means what? As I told you, that x0, x1, x, let me write like this. So here we have told you that x is equal to x0, x1, x2 dot 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 xn. So I say that, and y is equal to y0, y1, y2 dot 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 yn. So x dot y is equal to x0, y0 plus x1, y1 plus x2, y2 plus dot dot dot. And mod of x is equal to under root of x0 square plus x1 square plus x2 square. Similarly, you can find out y0 square. This particular quantity, what it signifies actually, if you use this particular vector, because n values are there, so into the m dimensional space, it would be a point. Similarly, y would also be a point somewhere. So if you draw a vector between them and you find out that what is the angle between them, the cos theta of that particular value is going to be represented by this. So you understand that if the theta is when cos 0 is equal to 1, means when the two items are very similar, then this value is going to come at 1. Otherwise, it is going to have the lesser value. If the two vectors are at the 90 degree, this value comes out to be 0. Okay, so this way you can find out that what is the similarity between two items. So similarity, it gives you the similarity. If the value is 1, highly similar item, aligned into the same way. If the value is 0, they are entangled, they are having the 90 degree angle between them. There is a small variation into this particular cosine that we are usually going to use later. That is called the Pearson correlation that is needed. That is done when you do a kind of correction on all these vectors. You say that this x vector, if I, for example, if x x, as I told you, x0 plus x1 dot 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 xn, it is there. You find out what is the average of this quantity. It means summation of all the x divided by n plus 1. You find out what is the average and you subtract this value with all these quantities. And then you utilize this new vector, that is x dash, to find out the cosine distance. Then it is called the Pearson correlation. This is an interesting quantity and it is very useful. We are going to see later. Okay. Now we want to see another very simple algorithm just for the sake of completeness, that is called the k nearest neighbor. Okay, this algorithm is for the classification purpose. If k items are given to, if some item is given to you and you want to find out what is the classification of that particular item, then you see that who are the neighborhood item, and based on that you can tell that what is the classification of that particular item. So I am going to give you an example. Can you please concentrate with me? Let's assume that these are the data points. Okay, these are the data points. Let's assume that these are the data points. So how some data points are red, some data points are actually green. And let's assume that k is equal to 3, where k nearest neighbor, k is 3. So what happens if this is a data point? It comes. So can you tell me what is the classification of this particular item, whether it is red or green? Again, k nearest neighbor says that you have to find out k nearest item. What is the k3 nearest item? So I have to draw a circle and find out a circle that covers 3 items. I think 2 items, 3 items. This would be circle. Am I right? So you draw the circle into this particular way. 3 circles are there. So what is the classification of this particular item? Red, because those 3 items are red. If this is the data point, definitely you understand that this time it is going to be 3. Again, in this way. And here in this example, you can see that earlier my circle was of this particular side, but this time when I wanted to find out the classification for this particular item, only this small circle suffices, because my objective is find out 3 items. If they are nearby, then my task is done. So what is the classification of this item? Green. Okay. Okay. Next item, this. Can you tell me what the classification of this item? Again, I have to find out this. Looks like that this is red, because one is, because we have to do the majority voting. The algorithm says that you have to do the majority voting, find out the k other items, do the majority voting. I have done the majority voting. I have find out, okay, this item is red. Okay, here, what is the classification of this item? Again, if anybody is sure, please let me know. I think this is the circle, and based on that circle, what the classification? It is green. Okay. So this is the k nearest neighbor. If you want to find out k nearest neighbor into the ML domain, you can do like that. Let us try to understand architecture of the content-based recommended. Okay, content-based recommended means what? What are the items the person has already purchased? Based on that, I'm going to tell him. How can we make that particular system? Again, some information would come to me from various sources that we have. I need to have a content analyzer that can filter out this, because what the person has purchased, if I give you a lot of information on that information may not be that much categorized in which you want to utilize onto the system. So you have to apply some kind of analysis tool so that you can find out that what is said into that particular thing. Then the output of this thing is going to be stored in a database. And then you are also going to profile the user, what kind of peoples are there, what are the things he have purchased. Those 2 things are actually I'm going to collect and do a filtering based on the things, that what are the things available to me, what new things we can approve, suggest to him, and we find out probability. And then the highest probability items are actually going to be shown to the user. Then we want to understand that what is the feedback of the user, whether he have purchased that or not purchased that, what is the feedback he is providing. And based on the feedback, again, I'm going to change my profile of the user, and I'm going to be in this particular loop. Okay. So very simple architecture. So let us see an example, and a more concrete and more relevant example to you. Here, and most of the time when you go and search for the recommender system, these kind of examples comes to you. So this is again an example where let's assume that these are M1, M2, M3, M4, M5, M6, and 7. These are the 1, 2, 3, 4, 5, 6, 7 movies we have. And these are the 4 peoples that we have, A, B, C, D. It's 4 users. This particular user have seen this movie given the rating of 4. Let's assume the rating is 1 to 4, 1 to 5. This particular person has seen this movie and given the rating 5. Movie 5 given the rating 1. So given the rating 4. If I want to compare that what is the relationship between A and B. So ultimately what I wanted to find out, what is the distance between A and B. Okay, I want to find out what is the relationship, how similar they are. A and B, how similar they are. Okay, so I have to consider that what is the thing that B has given. So from on the movie 1 he has given 5, here he has given 5, here he has given 4. So what do you think, whether they are similar or not? So looks like that they are similar because only movies that they have seen, they both have given the high value. So looks like that A and B are similar. However, if I want to compare A with C, can you tell me? Okay, I want to compare A with C. How can I compare them? So we can see that there are 2 movies that they have seen. Okay, so there is a better comparison because these 2 movies, both of them have seen. So can you say that distance of, if I say that similarity score is here 5, then what is the distance between A and C? They are more similar, looks like, okay, because they have seen 2 movies. Am I right? Can you say yes or no? These 2 peoples are more similar. Can anybody say yes or no? They are more similar?
Yes, sir.
Yes? Yeah,
Yes.
you can just type. Yeah. Okay. So it looks like that they are more similar because they have seen both the movies. But if you go and deep down and try to see that what is the rating, you find out, okay, this movie he has given 5, but he was giving 2. Second movie he was giving 4 and he was giving 1. However, they have seen 2 more things, two movies together, but looks like that they are not similar. Understand? So no. So therefore, in this particular answer, this should not be 10. What should be this? This should be maybe 2. They have seen 2 movies. Okay. All right. So here, by this understanding, we have understood that AB seems to be more similar, but AC need not to be that much similar. So how can we find out that how similar they are? Maybe we can use some technical methods. So one method is a Jacquard similarity. What is the Jacquard coefficient? It is something like this. Jacquard formula is this, that says that RA intersection RB, okay, RB divided by RA union RB, okay, this value. So if you want to find out the similarity between A and B, you have to see that at how many places you can compare them. 5 places. How many places? 5 places. 1, 2, 3, 4, 5 places. They are okay. So out of 5, what is the similarity? At this place only they are similar because they have seen this particular movie. This is the Jacquard score. All right. If I ask you that what is the similarity between A and C, what is the similarity between A and C? Again, you have to see that this thing and this thing. How many places they have seen? One movie. 1, 2, 3. 1, 2, 3. These movie has been seen. So total movies seen. How many movies have been seen? I think this is number is 1, 2, 3, 4. 4. And out of them, what is the similarity? 2 by 4. Okay. So whether this is a right measure to go ahead with, 2 by 4 is higher. 2 by 4 is higher as compared to the 1 by 5, and this is counterintuitive to our understanding. So therefore, we cannot use this particular method because the values that we are going to get, they are not in concurrence with our understanding. This is not a right way. We cannot use a Jacquard similarity. Okay. Can we use the cosine similarity? Again, cosine similarity, how can we find out? As I told you that to find out the cosine similarity, you have to find out the dot product of the vectors. Dot product of the vectors. So what is the vector? So A vector is this, B vector is this. So you have seen that cos theta is equal to, you see that the dot product A and B, you see the dot product and their norms, you divide by the norms. Norm is nothing more than this, that you take the square root of the square terms, summation of the square terms. So I have to find out that what is the term by term multiplication. 9 plus, let me put 0 over here, because there is no other way, because values are not provided, it becomes 0 0 0 0 0 0. So 9 divided by, because this value comes out to be 9, and you can find out similarly what is the value of these two quantities, and you put them into the formula, you get 0.038. Similarly, you put using these two vectors, if you put these things, you get 0.32. So it is a good thing. It is a good representation. Whether the cosine is a good way to go ahead with this further similarity? Yes. Why? Because you know that the things which are more similar, their score should be higher. So you can see that here 0.38 value is there, here 0.232 value is there. This value is higher, therefore it is better. So my representation using the cosine similarity is a better way to represent. But marginally, because you can see that however they are similar, it is showing the similar, but the difference between them is very less. Looks like that this particular method using cosine similarity, we have discovered that similar A and B are more similar as compared to the A and C, but the difference is very less. So it is not a good way. Can we further improve it? So let us see another method, that is centered cosine. What is the centered cosine? You find out that what is the average of these values. So 4, 5 and 1. So 6, 6, 10. So 10 by 3. The average is 10 by 3. You subtract 10 by 3 by these values. 10 by 3 minus 10 by 3 minus 10 by 3. Similarly for here also, you subtract those values. Of 5, 5, 10 and 4, 14. So it is 14 by 3. My 5 minus 14 by 3. 4 minus 14 by 3. Similarly, you modify all these vectors and then you compute the cosine as few minutes back we have computed. If you do the computation, you would be getting different values. For example, when you find out what is the similarity between A and B, you get 0.09. What is similarity between A and C? It is minus 0.56. So this is a better measure. All right, this is the better measure. Okay. So why this is a better measure? The reason is that here we have placed actually 0, and 0 is not a good representation because person has not provided any value. How can you say it's 0? Okay, how can you say it's 0? If you say it's 0, it means that actually you are going to put heavy penalty over here as compared to the places we have provided the values over there. So what happens that if you when you apply these kind of methods, the average of all the feature vectors becomes 0. So because of this, things get normalized and you get a better representation. Okay. So how you can predict the rating? For example, if for the Mr. A, because A has seen what movies? A have seen only 3 movies. A have seen only 1, 4, and 5. If I want to understand that what is the rating the person is going to give this particular 6 movie, if I can know that what is the rating he is going to give this movie, what is the rating he is going to give to this movie, what is the rating he is going to give them, then I can pick up the one which is going to have the highest value, and I can give that particular movie as a suggestion to A. How can I build a recommendation system? I find out that what is the value over here, and whatever the maximum value is there with the movie related to that particular value, I am going to tell to the people to the A that would you like to see that? Okay. All right, very interesting. So how can we find out this value? This is again a question. So again, very simple thing that you can apply. Let me say this particular thing to you before going to go ahead further. Let us assume that the rating of Mr. X, and X is in our case, who is X? A. I'm going to find out for A. Is going to be Rx. Let me say that this value is Rx. Okay. And Rx I have to find out. Okay. I have to find out that what is the rating A is going to give. Actually, we have to find out. So the answer is this, that for this particular item, because because what we assume, not too many peoples are there. For this person, I am going to find out who is the similar item. For all the items, I am going to find out who are the similar item. Okay, and out of them, I am going to select n peoples. What is the n? Let's assume that I say that 10 peoples. How to find out nearest neighbor? We have few minutes back seen. So 10 peoples I am going to collect. So with the A, how many people? N number of peoples I am going to collect. Okay, those people who have rated for this particular kind of movie. If I want to find out that what is the rating of this particular movie, for example, movie 5, so I'm going to find out 10 those peoples. Once again, I'm going to pick A. With this, I am going to make a set where I'm going to put n number of people, say maybe person K, person M, person X, person Y. I have created how many people? Let's say 10 people. So I'm going to find out with who have also given the rating to ith movie. Okay, and then I can similarly I can simply see that what is the rating that has been provided by the people who are inside, and I take the average of that thing. Most probably the person is also going to give the same rating. If I by this way, if I can find out the rating of this thing, I can find out the rating of all of them. Then I can find out which is the maximum rating, and then definitely I can show to the person. However, the better it would be better that if we can do the weighted. Most of the time, simple average is not that good, and the weighted average is definitely going to be the better than these kind of quantities. So weighted average is again the fine, because you know that when I have collected the peoples over here, I know that what is the similarity between A and this particular people. Okay, so for every person who are there in my set, that particular item n is in my set, whoever is there, for each of them, I want to see that what is the similarity of that person with me, and how much he have, the Y has given the rating. I find out the summation, and then I divide by just a summation by to make it into the 0 and 1. So by this, we can find out that what is the value. Very interesting method, and this is called the user to user collaborative filtering. This method is called the user to user collaborative filtering, because I have used one user, I have find out that who are the other user nearby him, and then utilize this value to find out what is the rating, and based on the rating, then I can tell that who is that particular person. All right, so this is user to user collaborative filtering. Any questions on that? Okay. Next, we are going to see another thing that is called the item to item collaborative filtering. Okay, item to item collaborative filtering. Here, actually, what was happening that for every person, I am finding out that who are the other peoples who are into his neighborhood. Okay, in his neighborhood. Instead, why I am not going to concentrate on the item? For example, this item I want to find out. I see that who are the nearby item, and what is the opinion of the people on this particular item, nearby items. Use this information to find out that better way, into the better way, that what should be the rating, what is the possible rating that would be provided by the user. Okay, so if you do into this particular way, that you, for every item that you want to find out the rating, you go by that particular item, then it is called the item to item collaborative filtering. So let me give you once again the algorithm. Algorithm says determine the neighborhood of the item I, that who are who are into the neighborhood. Okay, because wherever the item is there, you can find out. We have seen that with the item, we can find out using the distance that who are the other item into the neighborhood. Okay, such that the user X has given a rating, such that the person has given the rating for those items, only for collect those items. Okay, obtain weighted score and normalize. What is the weighted score? Because let's assume that this particular person who happens to be X this time, I want to find out that what is the rating this particular person has given. So he has given R1, RA1, RA2, RA. Okay, rating to this particular item, third rating. I say for all the items I have a rating. And what is the similarity of that item with this particular item? Because this item has a similarity score, this item has a similarity score. What is the similarity? Based on the similarity, I have selected these items. So two items for, just see this particular formula. For every j that is there into neighborhood of I and x, Okay, I is the item for which I am going to find out. X is a for which I am going to find out. So I am going to see the whatever the nearby items are there. I am going to see that what is the similarity between these two items and what is the rating the person has provided to that particular item. I do this summation and I divide this by the summation of all the weighted terms so that again the value becomes normalized between 0 and 1. Use this particular method, and this is a different kind of rating. Using these kind of rating, all the items would be going to have a different kind of arrangement, and then I can pick that which is the item with the maximum rating, and I can utilize that, and I can show this to the person for the purchase. uh, Two methods we have seen: item to item and user to user. So if we do the practical thing, then item to item is going to outperform, means this is going to be the winner. Item to item is going to be winner. It is going to be the better method as compared to the user to user when I am going to do the recommendation. Okay. What is the reason why it happens? It happens because when I am going to find out the similarity, now the notion of similarity is more suitable for the items, because if I want to compare two peoples, if I compare, if you compare myself with somebody else, okay, if you compare two peoples, then whether you will be able to find out the right similarity? No, because peoples are not similar. They are, every people is different. However, we come up with some of the category that looks like that these two peoples are similar, but they are not similar. But for the items, it is more likely. If you go and purchase some biscuits, so all the biscuits can come into the same category. But you, in the same way, you cannot tell that this person is of the one kind and this person is of the another kind. People are not like that. Even if whatever kind of category we can come up with, always there would be exceptions, and that category would not be good. Okay, so that's why the categorization is good on the items, and that's why this kind of, when we are going to utilize this kind of notion of weighted categorization, then it would be more suitable for the item to item similarity. So that's why it is going to be the better method. Make sense? So, however, when we are going to build a recommendation system, so there are few challenges that actually comes in our way, and they must be handled with care. They are not very easy to go ahead with. And the first is the cold start. What do I mean by this? I mean, actually, what happens now? You want to for some person, for example, there is a person A, and you want to find out the recommendation for him, but he have not done any kind of purchase initially. When you start the system, he have not done any kind of purchase. After 1 year, you know that everything. When you are the first time coming to the system, then you don't have any data. Your data is not available to anybody. What to show to him? Very difficult. So therefore, it is called the cold start. For the new people, so you don't have the data. Big problem. For the new people, you don't have the data. What are the things you can suggest? Number one. Second thing is sparsity. Sparsity is again a very big problem, and but there is no solution of that. What happens that you know that if you go onto the Amazon and want to purchase some item, how many items are there? Crores of items are there. Crores of items are there. Different kind of items are there. But how many items you can purchase in your whole life? Maybe 1,000 items, 2,000 different kind of items. You don't do purchasing every day, na? Rarely you do purchasing in every day. Even if every day you do the purchasing, then only 350 purchasing you can do. 1,000, 2,000 purchases are too much. So out of the number of available item, the person, even if he is very frequent, the inputs that he is going to provide is going to be very sparse. Means he is going to provide, he is purchasing very less item. So therefore, getting the right thing means all these methods are very good, but when we have data now, who is going to give me the data? Person is not going to purchase everything and tell me that how good that particular item is. So sparsity is again a big problem. You understand this? Sparsity is a big problem. And the third problem is scalability. Because number of items are very large, most of the time number of users are very large. If you have database of all the peoples in your country, there are 100 crores, more than 130 crores of the peoples, everybody what the item they have purchased. If I create this kind of table and with respect to all the data items over there, the table becomes too large, and therefore it is very difficult to scale when the number of items are going to be increased, when the number of person is going to increase. So these are the big challenges when you actually develop the recommender system. Make sense? So with this, we come closer to our final slide, that is the conclusion slide. So we have seen that the recommender system, they are actually the software tools and the techniques that we utilize to propose that what are the suitable items for the person, and they are useful to increase your sales, and that's why very much important. Very few people, however, work in this particular area. I want to call upon multiple persons who are here present. Try to solve some problems into this particular domain. Definitely, you would be able to make a lot of money. Okay, can be achieved using the content similarity based approaches, where we find out that which items are similar. Based on that, we can find out, or the collaborative filtering, where we use the what other peoples are purchasing, and then we can apply that thing on the system. We have also seen that item to item collaboration is better as compared to the user to user, because users are more diverse and items are less diverse, and therefore if you go by the items, your probability of getting correct is going to be very high. Thank you very much. That's all for my side. Wonderful teaching you, wonderful talking to you. So if you have any questions, please let me know. We can
Sir,
discuss.
thank you, sir, for such a wonderful talk. I hope the knowledge you imparted would definitely motivate and inspire the research community and the different faculty members of the country in the area of AI and ML. Now I request the participants, if you have any queries about the topic, they can share with the message box or can directly ask to Kamalesh sir. Any questions?
Hello.
Yes.
Hello,
Sir,
sir. Can I ask one? Hello, this is Anirban Bose speaking. Can I ask one question to you, sir?
Please go ahead. Yeah.
Okay, sir. In the last couple of slides back, as you have said that, like for example, that I have opened an account in Amazon Prime Video. Okay. So there is no way that Amazon can understand that I was being a user of them, and still they can to recommend some movies or maybe something like that to me. And you said, I think you have actually pointed out that this is a problem of cold start problem or something like that. So how
Yes,
to overcome that problem, sir?
So one method we have also discussed, that they can utilize the locality information, na? From where you are. What are the people seeing over there? Okay. Because
Locality means, sir, the geographical position.
geographical location, yeah, from where you are.
Acha, acha. Okay.
Yeah. So they can start by this, and after that you'll be seeing few movies, and they can then build something like that.
Okay, and okay, can I ask one more question, or is it?
Please.
Okay, sir. Thank you very much for your patience. And one other thing is that in the beginning of the slide, you have mentioned something of technique known as hybrid one. So in the hybrid one, may I assume that whatever you are saying regarding the content-based method and that collaborative filtering based method, or maybe I am actually using these terms wrong probably. So they can be, merged together and put it in a single method, something like that.
Let me give you the idea.
Okay.
So what you can do, that we have mentioned that you want to propose some items to the person, okay? And the list is very large. Okay. So you apply the collaborative filtering, you find out that looks like that these 50 items I have to propose, and looks like that their probabilities are not very different. Their probabilities are similar. Then you can go back to that particular person's account and see that what he have purchased earlier.
Okay.
And now you apply those kind of information on this particular list, whatever that shortened 50 items list, and then you can find out that which is the more relevant for him.
Oh, in that way,
one idea.
actually,
This is one idea. You can think you can think multiple ways out of that. Okay. Yeah.
Okay. Thank you, sir. Thank you for the information. I mean, much appreciated, sir. And thank you for the enlightened talk that we had. Thank you, sir.
Thank you.
Sir, one more question comes to the chat box. One, that is the how we can address the issues and challenges of recommender systems.
So as I told you that the issues are there, three issues that we have discussed, that cold start, and I think Anirban has actually asked this very interesting question in that particular line only, that how can we do the thing collaborative filtering if we don't have anything. So the one method that I suggested you, that you can utilize that from where the person is called, person has been login. If he's an Indian person, we can show him the different kind of thing. Maybe his age, maybe his name, and some of the things we can utilize. So we can start. And after starting, when we start getting the data, then definitely we can train the better model out of that. Hope it answered the question.
Okay, sir. Thank you, sir. So now I request